In this lesson, we're going to be talking about solving multi-step linear equations involving fractions. All right, so we've already kind of done this a little bit, but we haven't had a lot of fraction work up to this point. So in Unit 3, we're really going to focus on making sure we know how to multiply, divide, subtract, add, all involving fractions. So it says to eliminate a fraction, we need to multiply each term in the equation by the denominator of the fraction. If there is more than one denominator, you must multiply each term in the equation by the common denominator. And we're going to kind of go over what that means in these examples. All right, we do not like working with fractions. I'm sure a lot of you don't like working with fractions. We want to work with whole numbers. So the way to do that is to eliminate them before we get started. So I see in this first question we have x divided by 2. We have a denominator. Oh, here we go. A denominator of 2. So to get rid of that, what we have to do is we're going to multiply this entire equation by 2 to ensure we don't have any fractions when we start kind of solving it. So I'm going to write this. I'm going to write 2, and I'm going to multiply each term in my equation by 2. And by multiplying everything by 2, right, we'll see all of our fractions will disappear. So we see here 2 times x divided by 2, the 2's cancel out, and we're left with just x. 2 times 5 is 10, and 2 times 19 is 18. And now we have a nice one-step equation. We'll move the 10 to the other side, and we'll get x equals 18 minus 10, or x is equal to 8. Right, so once that fraction disappears, it kind of turns into a very nice equation to work with. All right, we're going to see that in the next one as well. We have 1 plus x over 4 equals 6. Again, we want to get rid of our fraction. So we have to multiply everything by 4. So we'll get 4 times 1 plus 4 times x divided by 4 equals 4 times 6. From here, 4 times 1 is 4. These 4's cancel out, and we'll be left with plus x is equal to 24. And then we'll move the 4 to the other side and get x equals 24 minus 4, which is equal to 20. Oh, there we go. All right, same thing here. We want to get rid of our denominator. So that means we're going to have to multiply both sides of the equation by 3. So 2x over 3 equals 3 times negative 12. The 3's cancel out. We're left with 2x equals negative 36. And then we can divide both sides by 2 to get our negative 18 as our answer. All right, so once that fraction disappears, it gets a lot easier to work with. Let's do the same thing. We got lots of examples here. We see we have a denominator of 2. We'll multiply the entire equation by 2. All right, equals 2 times 5. And now we can simplify. The 2's cancel out. We're left with the y minus 6y equals 10. Then we can simplify y minus 6y equals negative 5y equals 10. And we'll divide out both sides by negative 5, leaving us with an answer of negative 2. All right, and now in the last example here, we have multiple fractions. So we have to find a number that's going to eliminate both fractions. So if I eliminate the whole thing by 2, because we have a 2 here, well, this first fraction has a denominator of 4, negative 4. So 2 is not going to get rid of that denominator. Now the smallest common denominator between 2 and negative 4 All right, if I multiply everything by, let's say, -4, 2 goes into 4, and -4 goes into 4, which will end up canceling out both fractions. So we have to choose, it's called the lowest common multiple, all right, of both numbers. So as you see here, if I multiply everything by -4, then again it says plus -4, I'm going to put brackets around it that time, times 2 equals -4 times 3/2. Let's see how this works. So in the first one's nice because the -4 and the -4 cancel out, and we're just left with x. In the second term, we have -4 times 2. So if I write plus -8, well, that just really means plus -8 just means x minus 8. Because that's a -8 there. And now on the other side of the equal sign, -4 times 3 divided by 2. We can't do any canceling here, so let's just kind of do this in our head. -4 times 3 would be -12, and -12 divided by 2 equals -6. So in here we'll have a -6. And now let's solve. We'll move the 8 to the other side, and we'll have x equals -6 plus 8, which equals 2. And in the very last example, again, we have two fractions. One denominator is a 2, one denominator is a 3, and the first number that 2 and 3 both go into would be 6, right? Because 2's multiples are 2, 4, 6. 3 goes 3, then 6. That's the first number they both go into. So we'll multiply everything here by 6. So what will this leave us with? Well, 6 divided by 2 would be 3, and 3 times -x will have -3x plus, well, 6 divided by 3 is 2, so 2x. And that's going to equal 6 times 9, which is 54. And now let's collect like terms. -3x plus 2x is -x equals 54. But we don't want the answer for -x. We want the answer for positive x. So we have to do the opposite. So we could divide both sides by -1, which will leave us with x equals -54. And we're done. All right, so it's just that first step here that's a little bit different, which we are eliminating our fraction right off the bat. So it says check that x equals 6 is the solution to the equation. So they're giving us an answer. They're saying this should be right. Make sure by doing a quick check. So we're going to set up our left side equals right side check. The right side just equals 5. So we don't have to do any work there. We have to check that 2x divided by 3 plus 1 is going to equal 5 when we make x 6. So let's do this first. So when we have a fraction, we're going to have to kind of simplify that all at once. So we have to do 2 times 6, which is 12, and 12 divided by 3 is 4. And then 4 plus 1, we know is 5. Look at that, 5 and 5. Our left side equals our right side. All right, so we just finished example 2. Now let's jump down to example 3. Now this question here is going to be a little difficult. All right, and I think the answer for this one's going to be a little bit high. All right, but I'm just using bigger numbers just to get you more comfortable with how this works. Okay, it's okay if the answer doesn't exactly make sense. That wasn't really what I was aiming for here. I just want you to get comfortable that just because numbers are big doesn't mean, all right, that the answer has to be wrong. So here we have a question where he said, Dwight is a race car driver, and they give us this formula with all of these values in it. They have D represents distance, V represents starting speed, all right, in meters per second, T represents time, and A represents the acceleration of the car in meters per second. So they're saying, what is Dwight's starting speed, V? So they're asking us to solve for V, and they're giving us a bunch of information. They're telling us first that Dwight travels 53,000 meters. So that's his distance. So his distance traveled is 53,000 meters. All right, they're telling us that he's accelerating 24 meters per second. So his accelerating is 24. And his time is 30 seconds. So we have to solve for V given all of those values. So let's write our equation. The equation was D is equal to V times T plus 1/2 AT squared. So we have a fraction in this equation. So let's just multiply everything by 2 to get rid of our fraction. So that will be 2 times D. Oh, and let me get rid of all this stuff down here. All right, I just wanted to double check to make sure the answer was right before I started this. I think we're okay. So 2 times D, let me clean that up. 2 times D is equal to 2 times VT plus 2 times 1/2 AT squared. All right, and that 2 will cancel with that fraction and we'll be left with 2D is equal to 2 VT plus AT squared. So now let's substitute our values in. D, they told us, was 53,000. All right, 2, we don't know V, but we know T is equal to 30, plus A, which we know is 24, T, which we know is 30, squared. Now we got to simplify and solve. So let's check here. 2 times 53,000, that will be 106,000. Now 2 times V times 30, we cannot do 2 times V, but 2 times 30 will give us 60V. And then we can do the last one here. So 24 times 30 squared, remember, 30 squared means 30 times 30. So 30 times 30, then times 24, gives us 21,600. And we have to solve for V, which means that 21,600 is going to jump over to the left side. So 106,000 minus 21,600 is equal to 60V. When we do 106,000 minus 21,600, we get 84,400 equals 60V. And now when we finish off to divide by 60, all right, we're going to get a big decimal answer, but we'll round it to 2 decimal places, so we'll get 1406.67 equals V. Remember, V is the starting speed in meters per second. So now we just need our therefore statement. Therefore, the starting speed of the race car is 1,406.67 meters per second. All right, which is crazy fast and honestly in real life very unrealistic, but all right, the purpose of that question was just to get you more comfortable working with some bigger numbers and getting decimal answers, okay?